Well, here we are on Wharekauri Beach on the very north coast of Chatham Island, pretty much bang in the middle of the north coast. And we're actually within a reserve, the Chatham Island Oystercatcher Reserve, that is maintained by DOC here. And every year, oystercatchers attempt to breed here. So what we have here are pillow basalts that have been dated at 5 million years old, and a pillow basalt is a basalt that flows into water. It could be fresh water, but in this instance it's seawater. When lava meets water, you end up with some spectacular features. It looks knobbly, and these lavas would have been extruded on top of sediments on the actual sea floor itself. And we know this because we can actually find bits of sediment that have been caught up and baked by the hot lava. And I've got some examples over here. Come and have a look. So here are a couple of rocks, and you can see this is a really tough rock. It's like a natural ceramic in actual fact. So this almost certainly relates to the sediment immediately beneath the basalt lava here. And I've got another example, something similar, and this is fossil bearing. It's actually loaded with bits of shell, and you can see some bits of scallop there. And I dare say that this too was on the sea floor at the time that the lava was extruded. We know the age of this lava very well because it's actually bristling with a mineral called Hornblende. And Hornblende is potassium bearing, and it's a very distinctive feature of all the volcanoes that are about 5 million years old here in the Chathams. Let's have a look at these amazing crystals of Hornblende, and you'll see them everywhere. Here's a really large specimen, or example. It really is quite black, and it's shiny because, of course, it's crystalline, and the crystal faces reflect light beautifully. So not only do we have hornblende crystals in this rock, but we also have xenoliths. Xeno meaning foreign. So here's a lovely example. It's a lump of foreign rock, quite different from the actual basalt. This must have been ripped off within the magma chamber at depth, I don't know, perhaps 50 kilometers down, and it's been brought to the surface in the lava at the time of the eruption. So the lava would have been liquid, right? But it's come up and it's brought up all these solid crystals and xenoliths. So it's a fascinating lava. Part of the structure of this rock, the appearance, this sort of knobbly structure, is that the lava comes out and sort of builds up on itself, and it sort of goes plop, blop, blop, blop. And this is the classic nature of pillow lavas. They're called pillow lavas because they have a pillow shape. So they end up with a skin like a sausage, and then the fluid pressure keeps coming and it breaks through the skin, and then you end up with another skin, and so you end up with these funny little structures. This is the amazing Splatter Rock, as the locals call it here in the Chatham Islands, and you can see why. Really, it does have this quite spectacular sort of radial lobate structure. So you can imagine the lava being squashed, and it's going in every which way into the sediment. You can see the splatter effect, just like I don't know, it's like standing on a tube of toothpaste, right? And it just goes, blop,